3.2 Solving simultaneous equations by elimination. This is the second method out of three that we're going to learn to solve simultaneous equations. Simultaneous equations can also be called systems of equations. I might call them both things. So we're going to start with the system or the set of simultaneous equations that I have right in front of you. And we're going to solve this using the method that we did in the first lesson, 3.1. X plus y equals 6, x minus y equals 1. So in order to solve this system, we're going to first graph them. So I'm going to subtract x and get them into y equals mx plus b form. So this equation has a y-intercept of 6 and has a slope of -1. So I put some points on there. I'm going to use my ruler function and hopefully get a good line in here. Okay, now I'm going to use my I'm going to graph my other equation. This one is not perfect. Let me just try and tweak it just a little bit because in a minute you'll see that I need to do that. Okay, that looks better. With a ruler you can be really precise. Okay, so now we're going to go ahead and go to this equation. I'm going to solve this equation. So I'm going to subtract x on both sides, which gives me -y equals -x plus 1. But I can't have a -y on the left-hand side. So if I change it to a positive y, that means that the signs on the right-hand side of my equation are going to change. And so I'll get y equals x minus 1. There are several ways you could solve that equation for y, but ultimately you'd get the same result. So my y-intercept is -1. And my slope is +1. So I go up 1 over 1, use my ruler function, or in your case, a real ruler, and get it just right. There we go. Okay, so now I'm looking for my solution, which is the overlapping point, which is right here. And looking at this one, hopefully you can see, it's kind of small, but hopefully you can see that I don't have it on a perfect intersection of blue lines. So I have to estimate my solution here. So what's the overlapping point here? Well, it looks like it's 1, 2, 3.5, let's say, and 1, 2.5. So the point of intersection, or the solution to this systems of equations, is 3.5, 2.5. Well, I don't really know that it's 3.5, 2.5. It might be 3 3/5, which is close to 3.5. I'm estimating just by looking at it. So there's got to be a better way to do this problem. We've got to use algebra to do this problem. Sometimes you don't always know going into a problem if you're going to get something that needs algebra, but a lot of times I choose algebra anyway because graphing it can be a little bit cumbersome. So here's the same problem, and now I'm going to use what's called the elimination method to solve this set of simultaneous equations. So I'm going to stack the two equations on top of each other. They are in standard form. I like the form they're in right now, and I'll talk about that in a minute. I'm not going to change them into y equals mx plus b. So I line them up so the x's line up, the y's line up, and the numbers line up. And my goal is to eliminate, that's the name of the method, I'm going to eliminate one of these variables. So what I'm going to do is I'm going to add the two equations together and see what happens. X plus x gives me 2x. Y plus -y cancels or eliminates. And 6 plus 1 gives me 7. The equals will just transfer straight down. Now I'm going to get x by itself, which is just solve for x, and I'm going to divide by 2, and I get x equals 7/2, which is the same as 3.5. Well, that is what I got in the other situation when I graphed it. How do I get the y component? Well, I have two equations. 3.5 is the x. All I need to do is plug in. Extend my page a little. So I have x plus y equals 6. It doesn't matter which equation you use. I'm going to plug 3.5 in for x, and I'm going to solve for y. Subtract 3.5, and I get y equals 2.5 is what that problem would give me. So now my solution is 3.5 for x, 2.5 for y, which is what I got using the graphing method, but this didn't involve any graphing at all. To check my solution, here's my check step. I'm going to use the other equation, the one that I didn't use at the very end when I plugged in. This was the other one. Okay, I didn't use that down here at the bottom, so I'm going to use that one now. X minus y equals 1. And I'm going to plug my point in and see if it works in this equation. So I've got 3.5 minus 2.5. And does 3.5 minus 2.5 equal 1? It does. So I know I got it right. So my final solution for this system of equations is 3.5, 2.5. Got a little funny on me. Okay, so here's another situation that I'm going to do. This is, again, two equations, systems of equations. They are both in standard form, and notice how I mentioned standard form right here. Ax plus by equals c. So basically, a is going to be a coefficient of x, b is going to be a coefficient of y, and c is going to be a constant. And if you can force an equation into this format, in fact, force both of them into that format, then you can use the elimination method. So I have two equations here. They're both in standard form, so I'm going to add them together. Negative 2x plus positive 2x cancels. 3y plus 3y, 6y. 12 plus 12, 24. Divide by 6, and y equals 4. Now this time I solve for y, and it doesn't matter which one you solve for. You can solve for either one because your goal is to get an x and a y. So for my final solution, sometimes people forget the final solution, so it's sometimes helpful to give yourself, you fill this in, like you leave it blank and then you fill it in. You know, okay, that's what I'm shooting for. That's going to be my final answer right here. So what did I just get? I got y equals 4, so I know this goes in the y position. So now what do I do to get the x? Well, I've got to plug it back into one of my equations. So I've got which equation do I want to use? I think I'm going to use the positive one because there's no negatives and that might make it easier for me. So 2x plus 3 times 4 equals 12. 3 times 4 is 12. And I'm going to recopy everything else. Subtract 12 and I'm going to get 0 equals 2x. I'm running out of room here. Divide by 2. X equals 0 divided by 2, which is 0. So 0, 4 is my solution. So now, just to check it, I could plug that point into the other equation, or I could graph it. If I was going to graph the first one, let's take a look at the first one. Negative 2x plus 3y equals 12. This is going to take a lot of work, so I'm going to add 2x to both sides. I'm going to get 3y equals 2x minus 12. Divide by 3. Y equals 2/3 x minus 12 divided by 3 is 4. So my y-intercept is 1, 2, 3, 4. My slope is up 2 over 3. Up 2 over 3. Use my ruler function to connect those points. Ooh, I got that one the first time. Nice. Okay, so now I'm going to go to my other equation, do the same thing. This one does not have the negative in it. 2x plus 3y equals 12. Subtract 2x on both sides. I get 3y equals negative 2x plus 12. Divide by 3. Y equals negative 2/3 x plus 4. Well, oh my goodness, you can see right away they have the same y-intercept, which actually this is the y-intercept, right? Slope is negative 3 down 2 over 3. So it's going to be facing the other way. And if I use my ruler function just to complete the equation, you will see that their point of intersection is the y-intercept 0, 4, which I got up here. Okay, so we use method 1 down here, we use method 2 up here. And you'll learn another, in the next section, you'll learn method 3. Okay, let's go on. We'll do 2 more. These 2 we will not do the graphing portion. We're just going to do the elimination method. Notice how they don't line up. They're not both in standard form. The second one is in standard form, but the first one's not. So I need to make it match. Basically, I need to move my x over. So I'm basically going to subtract x on both sides. And I'll write it over here. I'm going to have negative x plus y equals 2. This one stays exactly in the format that it's in. I'm not getting good writing here. Plus 2y equals negative 2. And I'm going to add the two equations together. Negative x plus x cancels. Y plus 2y is 3y. 2 plus negative 2 is 0. So I've got y equals 0. Remember, I'm shooting for an ordered pair. I don't know the x at this point. I do know the y is 0. How do I find x? Oh, right. Plug it into one of the equations. So I think I'm going to choose the second equation here. It doesn't matter. You can do whichever one you want. X plus 2 times y, which is 0, equals negative 2. So that means x equals negative 2. Okay. If I wanted to perform a check step, I'd use my first equation, y equals x plus 2, plug in the ordered pair that I got, which looks pretty messy here, but x is negative 2, y is 0. Does negative 2 plus 2 equal 0? It does. So I know that this is my final solution. Okay, I'm going to erase this one a bit because it's in my way. So now I've got x plus y equals 27 and 2x plus y equals 39. Now, these are set up in standard form already. But if I add x plus 2x, I'm going to get 3x, see? And if I add y plus y, I'm going to get 2y. So did I eliminate a variable? No. I still have an x and a y equals whatever 27 plus 39 equals. So I need to come up with a better idea. Well, guess what? You don't always have to add. You have another option here. You can subtract. Okay? So if I subtract these two, I'm going to have x minus 2x. Well, that's negative 1x. Y minus y cancels. 27 minus 39. What does that give me? 7. Good. 12. How about 12? Sorry about that. Slow subtraction. So let's go back. So that's negative 1 equals, if I have 27, take away 39, I will have negative 12. If I do the math on that, divide by negative 1, I'll get x equals 12. Now I need to find y. Well, I'm going to choose my first equation to do that. X plus y equals 27. I plug in 12 for x, and I get subtract 12. Y equals 15. So the solution I've got here is 12 comma 15. And I'm going to use my second equation to check it. Now the check step is actually optional, but I just want to show you several times so you know how to do it. I've already used x plus y equals 27 here, so I'm going to use 2x plus y equals 39. X is 12. 2 times 12 is 24 plus 15 equals 39. Does 24 plus 15 equal 39? It does indeed. So I've got my final answer right there. Okay, one more situation, the hardest kind of elimination method. When you put them both in standard form, guess what? They don't line up. If I add them, I'm going to get something. Look, let me show you. If you add these two, you're going to get 1x plus 3y equals 16. I didn't eliminate anything, so that's not going to be okay. So let me get rid of that. If I subtract it, what's going to happen here? Negative 4x minus 5x, that's going to give me negative 9x. Y minus 2y is going to give me negative 1y. 1 minus 15 is going to give me negative 14. Did I eliminate a variable? No, I did not. So that's not going to work either. So what I'm going to need to do is I need to play around with my equations a little bit more so that I can force them. I notice how I force things a lot. Force them so that they match. So basically I want either the coefficients of my x term to match or the coefficients of my y term to match. And even more preferable would be one of them is positive and the other one's negative. So I could choose my x terms to change, or I could choose my y terms to change. I think what I'm going to do is I'm going to change my y coefficient so that I can make this one into a negative 2y. So in order to do that, I need to multiply by negative 2 across the whole equation. So that keeps the equation the same, but it doesn't change the equation. It just kind of changes the numbers, but in proportion, so they're going to still be equivalent. It's going to be the same kind of equation. So I'm going to keep the second equation exactly as is, but the first equation I'm going to make negative 4 times negative 2, what is that? Positive 8x. Negative 2 times positive y is going to be negative 2y. And negative 2 times 1 is negative 2. Now, I very easily could have multiplied this one all by 5 and this one all by negative 4, which would have had my x terms match up and be negative 20 and positive 20. But I happen to think this one's a little bit easier. So now if I add the two equations, I have 8 plus 15 is 13x. Negative 2y and positive 2y cancel. And 15 plus negative 2 is 13. And now it works out beautifully. So this is the most complicated of the methods because there's so many steps involved. I've got to get my y coordinate. I think I'm going to choose the top equation. Negative 4 times 1 plus y equals 1. Negative 4 plus y equals 1. Add 4 to both sides. Y equals 5. I have 1, 5. Now, is that my solution? Let's just do a check. My equation was 5x. I lost it. Let's see here. 5x plus 2y equals 15. Okay, and my solution was 1, 5. Okay, so now I'm just checking it. I'm putting in 1 for x. I'm putting in 5 for y. And I want to see if it equals 15. So I have 5 plus 10 equals 15, and indeed it works. So it's important, definitely on a test, to do the check step, because then you know you've got the right answer. And there's a lot of algebra and a lot of places you can make mistakes, so you do need to be careful. So that's the elimination method. Thanks for listening. Good luck.